Hey, boys and girls, welcome back to another edition of Think Different Television. Okay, so we are going to do our SOHCAHTOA missing side, but now with challenge questions. Ooh. So, why would you need to know SOHCAHTOA and why would we figure this out? What's the purpose? Well, what if we had a question like this? Follow along as I read. A person flying a kite originally lets out a 232 feet of line. So, here's the person letting out 232 feet of line, and there's their kite, B. At this point, the person observes an angle of elevation of kite of 48 degrees, okay? The person then lets out an additional line, a total of 312 feet right here. At this point, the person observes an angle of elevation 53 degrees. So you're flying two kites like this person. So how do you know how high the kite is? And how do you know how far apart they are? Those are things you can't just automatically do. But if you know how much line you're letting out and you know the angle, then you can figure out how high something is. So watch this. So I don't care about A and B because we're going to need to do that in order to find C. So find the amount the kite rose after the line was let out to the nearest foot. So 232 feet right here. You let out some line. Now it's 312 feet. How far did it rise right here? So B to C. That's essentially what you're trying to find. Pause the video and see if you can find that. Ready, set, go. All right, so these sort of steps are all on the way. So check this out. This is how I'm going to do it. Boop. So I drew my picture right here. So 232 feet right here. Person lets out the line, and it's 48 degrees. Then they let out 312 feet total of line, and then the angle increases to 53. So how far apart are they? That's X right here. But in order to do that, you have to actually do two problems first. So if this is A to B, that's what I'm trying to find first. So how high was the kite originally? This right here. So this was 48 degrees and this is 232. I want to know, let's call this X right now, how high it went at first. So that's going to be, this is the right angle, obviously. So this is a hypotenuse, and this part is your opposite. So you have opposite and hypotenuse. What are you going to use? Yeah, sine. So the sine of 48 equals opposite X over 232. Bam. Cross multiply, da-da-da-da. X equals 232 sine 48. You're writing this down if you didn't get it, because you're expected to do these on the ACT. 232 sine 48, bam, so this is approximately 172.4 feet. So this is approximately 172.4 feet in the air right now. So then you let out some line, and now the kite, so now I'm going to do a second one to sort of peel it off of this. So at 53 degrees, it's 312 feet. And so now you're trying to find this distance right here. So this big triangle is what you're sort of peeling off right here. So you ignore this part. So you sort of peel this off. And now I'm looking for, let's call this Y. So this big thing, this whole distance is Y, let's say. Okay? So this is the hypotenuse. This is opposite. I'm doing the same thing again. So opposite over hypotenuse. So what am I using? Yeah, sine of 53 equals opposite Y over hypotenuse 312. So, over 1, sorry. So it's Y equals 312 times sine 53. So calculate it up. 312 sine 53, and you have Y is approximately 249.2 feet. So 249.2 feet. Okay. So what do we find out? It's kind of cool that we can actually figure out how high something is without actually measuring it. So we're not even underneath. You're standing here and you actually can figure out the height if you know just this information. So that's how they measure the height of mountains and the height of tall trees and height of cliffs you can't climb, etc. So what do we do now? Oh, in order to find X, I need to take this big part and subtract the little part. So take the big part and subtract this, and I'm left with this, right? So 249.2 feet minus 172.4 feet. So 249.2 minus 172.4, and you get 76.8. So the distance x is approximately 76.8 feet. So when the person let out more line to 312 feet from 232, the kite rose 76.8 feet. There you go. So if you didn't get that, there you go. This is a good one just to pause and then just practice, see if you can do it again. Now, let's do some more challenge problems, shall we? Yay! Check it out. So these are the ones that I see at the end of ACTs. So this one's like number 45. This one's number, also 45. So these ones are the ones that are really going to put you over the top in terms of getting the score you want if you're able to get the ones late in the math ACT section. So, following as I read, a rocket lifted off from a launch pad and traveled vertically 30 kilometers or kilometers, then traveled 40 kilometers at 30 degrees from the vertical, then traveled 100 kilometers at 45 degrees from the vertical, as shown in the figure below. Okay. At that point, the rocket was how many kilometers above the height of the launching pad? Woo! Okay. So follow along as I do. So you got that picture. Copy that into your notes like I did right here. Okay? So the rocket goes here, here, and here. So it's asking for how high did it go from the station. So you're asking for this distance here. So we know that this is already 30, right? So what else can I do? Well, you know that this is 30 and this is 40, okay? But if I need to know this height here. So look, this is a triangle. So if I get this part, that's the same as this part here. And then if I get this part here, that's the same as this part. So I'm actually going to find this is x and this is x. Following as I think, because you need to make these connections in order to get the questions right on the more challenging problems. Let's call this y and this y. So if I'm able to get x and y, I add it to 30 and I get the whole dang thing. So this right here, look what I did. I just made a right triangle. And it says this is 30 degrees. So just focus on this triangle. If I want to peel it off, I can peel it off and help myself distinguish what is what. So I want this. This is x. So I label it. This is hypotenuse. And what's this side? Yeah, this is the adjacent. So cosine of 30, because you have adjacent over hypotenuse, equals adjacent x over 40. Boop, boop, boop. 40. So x equals 40 cosine 30. Calculator. 40 cosine 30. Bam. And so x is approximately 34.6. There you go. So this is about 34.6 kilometers. Okay, so now I need y, so I'm doing the same thing here. So here's my next one. So sometimes you have to make a picture when there's not one, like that. So this is 45 degrees here. So that would mean that this is the adjacent, and this is the opposite to 90, or is the hypotenuse. What am I going to use? Yeah, cosine again, because you have adjacent y and hypotenuse 100. So we have cosine of 45 equals y over 100. So cross multiply. Y equals 100 cosine 45. 100 cosine 45. Boop. You get approximately 70.7. Okay, kilometers. So this is 70.7 kilometers. So what do you do now? You have to add them up. You have 30 here, here, and then you got 34.6 and then 70.7. So 30 plus 34.6 plus 70.7, sorry, 70.7 is 135.3. Okay. So now let's look at the answer choices, shall we? Boop. I don't have that. So what am I going to do? Well, look at D and look at E. So I look at D and E. So let's try E first. So that's 30 plus 20 radical 3 plus 50 radical 2. So all I did was I copied e into my calculator. So I know the answer is about that. I know it's not exact because I had to round these two. So what do I get for this? Ooh, something really close, right? So that's about the same thing. I know it's not exact because I rounded this part. I rounded this one and this one. And so, yeah, E is the answer for that. Yeah. Cool. So E is the answer. All right. Now try this one on your own. Ready, set, go. All right, see what we got. Here's my picture. So we just need this one, and we need this part. So let's call this X and this Y. This is X, and that's Y. Okay. So if this is 60, this is going to be opposite, and this is going to be right angle, hypotenuse. Copy this down if you don't have it. So opposite over hypotenuse, what are you using? You're using the sine of 60 equals X over 60. Yeah. X equals 60 sine 60. 60 sine 60. So X is approximately 51.96. Cool. So 51.96 is this one. Is this, so this distance is the same. Okay, so now I need this. Ooh, let's just label it. This is a right angle, right? This is the triangle I'm looking at. So this is the opposite, and this is the hypotenuse. What are you going to use? Sine again, because you have opposite over hypotenuse. Sine of 45 equals y over a honey. Cross multiply. Y equals 100 sine 45. Okay. 100 sine 45 is 70.7. So we have 70.7, and we have 51.96. So 70.7 plus 51.96. 70.7 plus 51.96. So you get 122.66. Which one is similar to that? Let's see. Do I have anything? No, it's not A, B, or C. Let's try D. I don't know. Let's try D. 50. I'm putting this in my calculator right now. If you didn't do it, 50 radical 2 plus 30 radical 3. Yeah, there you go. So, check it out. The answer is D, because I put D in the calculator, and that's about the same because I rounded these two. So the answer is D. Good work, everybody. Way to embrace the challenge. Try these again if you need.